Hey, grade nines. So in this next lesson, we're going to go over solving linear equations algebraically. So just so you know, this video is especially important that you watch it because a lot of the examples in the PowerPoint, I actually didn't solve it fully. So just keep in mind that if you're looking at the PowerPoint and you're like, where's the solution? It's in the video. So you really have to watch the video as well. So just make sure that you're aware of that. So watch the video. Try the examples out yourself first, but it's very likely that you might get a little bit stuck. So if you do, definitely I would still keep the video running while you're going through the lesson itself, okay? So first thing, I'm just going to go over the big ideas when you're solving equations. So some of you have learned about solving equations before. So if you have learned about this, then this will be a mainly review for you. But maybe you haven't done more difficult examples. So these are kind of the four big ideas I would say. If somebody were to say, you know, what do you really try to keep in mind when you solve an equation? Well, first thing is you want to collect all your like terms. So what that means is if you have any, normally in linear equations, at least it makes it easy, but especially when you get to higher grades, it's going to get a little bit more difficult. But if you remember this concept, then you're pretty good. Essentially what you're doing is you're collecting all your variables on one side and your numbers or your constants on the other side. Okay, so in our linear equation, we're going to have x's all on one side and then you're going to have numbers all on the other side, right? That's essentially what we're saying. And now keep in mind, we use x as one of the variables, but it could be any variable, right? So it could be L or N or F, whatever you want it to be, right? So that's the first thing. You want to make sure that all your numbers go on one side and your variables go on the other side. Then what you're using to move them around, because you're probably wondering like, what do you mean by moving them around? You're using inverse operations whenever you want to change when you want to move one term or number to the other side of the equation. And you do this by using something called inverse operations. And again, inverse operations, you have learned about this before. You probably just never seen that word. It's basically operations that cancel each other out. So for example, adding cancels out subtracting, multiplying cancels out division, right? Squaring cancels out taking the square root. So multiplying and dividing as an example, if you put this in a calculator, I say 5 times 6, you get 30. And then if I tell you, okay, take 30 divided by 5, what do you get? Or sorry, 30 divided by 6, what do you end up getting? You end up getting 5. So basically multiplying by 6 and then dividing by 6 right after, it cancels each other out, right? So that's what I mean by inverse operations. There are operations that will actually can't eliminate each other. And the reason we want to do that is because and this kind of goes on to the next idea, when you're moving equations, you want to make sure that you're still keeping them balanced. So in math, I am allowed to change my equation. I'm allowed to perform inverse operations, but I can't just do that randomly, right? It doesn't really work that way. You're doing this to kind of keep everything in balance. So that's kind of our third point here, that if I were to perform one operation on one side, you have to do it to the other side. The best example I always think of this is teeter-totter. If you ever on a teeter-totter, way back in the day, maybe when you were little, you know that you have to keep the weights balanced. If not, the one person is going to go flying up, right? So when you're on a teeter-totter, you want to make sure, you know, if the one person is maybe a little heavier, you want to maybe lighten it up a little bit. Sorry, you maybe want to keep it more balanced. So you might want to put more weight on the other side, right? So essentially the whole idea is that if this side, your equation is basically like a balance beam, right? Like a teeter-totter. You're essentially saying I have two values that are currently completely equal to each other, right? So if this is one weight right here, one person on this side is supposed to be a person, and the other person on the other side, they're supposed to keep everything balanced, right? So if I decide to move something to this side, I can't just move it per se. I have to make sure that I do it on both sides and kind of keep them equal. So if I subtract off something from here, I have to subtract something off from that one as well. That's the whole idea of balancing an equation. And your last concept here is that you want to isolate for x. So your goal is to get x by itself. That's always your goal, okay? And whatever the missing variable will be. So that means that anything that is not x needs to be moved to the other side. So if you remember those four big ideas, then you can pretty much solve any equation, right? This is the big crux that you're really trying to understand, right? Um, So I'm just going to go to the next part here, and we're going to look at some examples. So these for a couple examples should be relatively easy, and maybe some of them you've done before, but if not, we'll go through them either way. So the first one, we have what negative 2x plus 4 is equal to 14. So what I'm going to do is I'm going to purposely leave a little bit of space, and the solutions are on the next slide for this one. Like I said, I didn't do the solutions for all of them, but in this case I did. So what I'm going to do is I'm actually going to show you kind of step by step what I mean by balancing. So first thing I would recognize is that you're trying to isolate for x. So x is kind of your goal. So I might want to just highlight this. So I'm just really well aware of what my goal is. My goal is to isolate for x. So what I'm going to do is I'm going to subtract, I'm going to take away the 4 first, because the 4 is the furthest away from the x on the one side, right? So I first recognize, so let me change that there. I first recognize that this, that the variables and the numbers are kind of all mixed around with each other at the moment. So my goal is to try to get all the x's, and in this case, there's only one x there, to leave it on one side, and that means that the numbers need to go to the other side here. So that 4 needs to be moved over here. Now, we just talked about this, that you can't just move a number. It doesn't really work that way in algebra, right? I can't just magically be like, okay, I'm going to put the 4 there because I want to put the 4 there. You're not allowed to really do it that way. But what you're going to do here is you're going to think to yourself, all right, if I do want to move that number to the other side, I can't just move it, but I can use an inverse operation. And that's what we just learned about. So the opposite of adding a 4 is to take away a 4, right? Does that make sense so far? So you're doing the opposite of adding a 4, you take away a 4. And then the idea here is that you're going to do the same on the other side. You're going to subtract the 4 as well. And then when you do this, you actually end up canceling this out. The 4 and the 4 actually become a 0, right? So 4 minus 4, you can check yourself, that's 0. And that's exactly what you want it to be. And then on the other side, I end up with 14 minus 4, which is a nice, easy number. That's 10. So I end up getting negative 2x is equal to 10. Now, what's my next step here? So my next step is to realize, well, I still have a number that's in front of the x. And I forgot to mention this verbally. I did type it down there. When you are solving using algebraically, solving an equation algebraically, you always want to use, you're performing your operations, but you're doing it the order is BEDMAS backwards. All right. So we actually want to get rid of the addition subtraction first, any adding or subtracting questions first, and then you want to get rid of you want to move any numbers that are being multiplied or divided by, right? So in this case, I'm multiplying by negative 2x. And again, how do I know I'm multiplying? Because when I have a number next to a variable, it's automatically assumed that I am multiplying. So what I'm going to do next is I am going to, and go back to using the same color here. I'm going to divide by negative 2 right there. And by dividing by negative 2, I know that negative 2 divided by negative 2 actually ends up giving me 1. And you can even put that in your calculator. Negative 2 divided by negative 2 gives you positive 1, which is correct. And so the idea here is that I need to do it to the other side as well to be consistent. So I take negative 10 divided by negative 2, and 10 divided by negative 2 ends up giving me negative 5. So my answer is negative 5. Does that make sense so far? Hopefully it does. And then I obviously see here that negative 2 divided by negative 2 gives me positive 1, and that's really what I wanted to do. My goal was to get x by itself. Now I could write the 1x and 1 in front of the x, but there's no point in doing that, right? If I just write x, it's implied that I mean 1x, right? That's really what I'm saying there. So that is how I solved my equation. Now, could you have solved this a different way? Absolutely. You could have done guess and check. You could try different numbers and see, negative 2 times what number plus 4 gives me 14. You could try different numbers until you get to your answer. But that's not a very good strategy. And that's maybe what some of you did in elementary school. It's just kind of speaking to you informally. I think some of you mentioned that you might have done strategies like that. And while that definitely can work sometimes, and there will be examples where that's quite easy and it works perfectly, it's not always the best strategy, because you sometimes are given really strange equations and you don't want to always be guessing and checking. It's not going to be a great strategy. So let's do the next one here, B. So for b here, I'm going to have x minus 4, sorry, x over 4 minus 10 is equal to 3. So what I'm going to do first is I'm going to think to myself, all right, well, what can I move? What's my first step? Well, I have the minus 10 there that I want to get rid of. So I'm just going to make a little bit of space. So I think to myself, well, what is the opposite of subtracting 10? The opposite of subtracting 10 is to add 10. And again, I want to get rid of the minus 10 first, not the 4 here in the denominator, because this right here, I know you kind of look at it as a fraction, but this is actually just division, right? You're probably going to start seeing that more and more, that we don't really use the division sign that much. We just start using almost fraction notation for it, right? So if I write x over 4, it's really x divided by 4. So I'm just saying some number divided by 4 minus 10 gives me 3. That's really what this equation is saying, right? Some number divided by 4 minus 10 gives me 3. So I'm going to think to myself, all right, well, if I want to get rid of the negative 10, I'm going to add 10 to both sides. So I add 10 to both sides, and then this ends up giving me x over 4. And the negative 10 plus 10, what happens here? Well, negative 10 plus 10 actually cancels each other out. And then we're left with x divided by 4 is equal to 13. So x divided by 4 is equal to 13. So now I have to think to myself, all right, well, how do I get the x by itself? Well, I'm dividing by 4 here. So I must think to myself, all right, well, what's the opposite of dividing by 4? The opposite of dividing by 4 is to multiply by 4. And you can check yourself. If I take a number in a calculator, doesn't matter what number it is. If I take, 100 divided by 4 and then I multiply by 4, I end up at 100. So if I simply multiply by 4, it cancels out that division by 4 there. But then remember, in math, I'm not allowed to just add a number whenever I want. I need to keep the equations balanced. So that means on the other side, I also have to multiply by 4. Right? And I'm doing this so I can keep it balanced. So I multiply by 4 on both sides, so I can get rid of the 4 in the denominator here, or in the division, right? You want to think of it as division. And then on the other side, I know I take 13 times 4, which is going to give me 52. So that means that x is equal to 52. Hopefully that's making sense so far. All right, so now my next question here, I'm just going to erase this if that's okay, so we can go to the next part. Okay, so now we have our second equation here. So we were initially given, so I'm just going to write out the original question. This is for C. So is w plus 3 over 4 is equal to 2. So first step is I want to get rid of the multiplication here. Sorry, I want to eliminate the division by 4 there. So I want to think to myself, all right, well, what is the opposite of dividing by 4? The opposite of dividing by 4 in this case would be 2, and sorry, I'm just trying to switch the color here for some reason. It doesn't seem to work. So I want to be able to get rid of, oops, let me just change that there. Okay, so I want to get rid of the division by 4, so I'm going to do the opposite of dividing by 4. I am going to multiply by 4. And then of course, that would eliminate this 4 in the division there, or you want to think of it as fraction. And then we know on the other side, we're also going to be doing the exact same operation. We're going to be multiplying by 4. So then we multiply by 4 on the right-hand side. Now we're left with w plus 3 is equal to 8. Now, what's my next step here? My next step is to get rid of the addition of 3, and then I want to do that on both sides, right? Whatever operation I use to get rid of that, I want to perform that on both sides. So I have w plus 3 is equal to 8. Well, if I want to get rid of the adding 3, I'm just going to subtract off 3 at the bottom. And I'd like to leave a little bit of space just so we write it all in one line. But if I write it underneath, I hope you understand it's the same idea. I'm basically just saying I'm going to, because I want to get rid of the addition of 3, I want to subtract off 3. So I subtract 3 on both sides, and then this ends up giving me 3 minus 3, which is 0, nothing. and then I end up with w is equal to 5, and I'm done. Now, one small thing I want to mention here, when you are like in this case, this might kind of throw some of you off because you're probably thinking to yourself, didn't we say BEDMAS backwards? And so wouldn't you want to get rid of the addition first instead of the division by 4? But in this case, it's a little bit different because you almost want to think of it as whenever there's a fraction whenever it kind of looks like one large expression divided by some number, you want to get rid of that denominator first before anything else. We'll talk about fractions. Fractions kind of confuse whenever you have an equation that involves a lot more fractions, it gets a little bit more confusing. But here, essentially, the idea is to get rid, instead of thinking of BEDMAS backwards, I sometimes think it's more helpful to think about eliminating the numbers that are furthest away from your variable step by step. So you want to get rid of the 4 first in the denominator because that is furthest away from the w variable that we're solving for. The 3, if you actually look at the 3 there, we're adding a 3 to w. That's actually quite attached to w, whereas the division by 4 is kind of if we think about it this way, it's almost further away from our variable w. Sometimes it kind of helps to think about getting rid of the numbers that are furthest away first, and then you want to get rid of whatever variables are directly in front, whatever numbers or coefficients that are directly in front of the variable there. Okay, so our solution here, so let's go to I'm just gonna skip over to the next part here. So we went through this. So now our next example, we have 3 minus d over 6 is equal to -1. So I'm actually gonna write it out first. And unfortunately, you can already see the first part of the solution, but I'm just gonna continue on here. So we have 3 minus d over 6, which again is, think of it as division, right? Is equal to -1. Okay, this one's a little bit tricky. I think it's just the structure of the question. So you would think that you would want to get rid of the division of by 6 first, but again, you want to get rid of what is furthest away from your variable. And right now I can see here that the 3 is actually quite a bit further away from, or it's more separated from the variable itself. So what I want to do first is I want to subtract off the 3. And and the reason I'm subtracting off the 3 is because this is, I know you don't see it there, but really it's a positive sign, right? It's a positive 3. So because it's a positive 3 and I want to eliminate the positive 3, I want to move it to the other side, I'm going to be subtracting off the 3. And then I do that on both sides here. So I subtract off 3 on both sides. Then I end up with -d over 6 is equal to, and of course this cancels out the positive 3 and the negative 3. This ends up with, we end up with -4. And our next step here, what should we do next? Well, we have -d over 6, or divided by 6 is equal to -4. Now, this fraction right here, there's a negative sign, and I know some of you have asked about this already. There is automatically a negative sign in front of the fraction, right? But we can think of it, and we talked about this already, and this will probably make it easier, we can put the negative sign in the numerator. And the reason I would do that is just so you don't have to worry about, the negative in the whole entire fraction. We can just simply think of it as -d, or some negative number, divided by 6 gives us -4. It might be easier to think of it that way. So I'm simply putting the negative sign in the numerator. It just makes it a little bit easier for me to solve this. So now I think to myself, all right, so I have -d divided by 6 is equal to -4. So what should I do next? Well, the next number I want to get rid of is 6. That's my next target. So right now I'm dividing by 6. So I have to think to myself, all right, well, what's the opposite of dividing by 6? The opposite of dividing by 6 is to multiply by 6. So I multiply by 6 on both sides. And when I multiply by 6 on both sides, I end up with -d, and I'm sorry, I'm going to go to this side over here. I end up with -d is equal to -24. And again, where did the 6 go? Well, it canceled out, right? Because If I divide by 6, but then I multiply by 6, I end up with just 1. So this actually, and again, when you do this, 6 divided by 6, you can do this in a calculator, you end up with 1. But remember, when we multiply by 1, that actually doesn't do anything, right? It doesn't change the variable at all. So now we end up with negative d is equal to negative 24. Now, at this next step, this is the part where sometimes people get a little bit confused. So you have negative d is equal to negative 24. So you have to think to yourself, all right, well, I kind of have my answer, but not really. The question wasn't asking me what is negative d equal to. It's asking me what is d equal to. So I still haven't given the full answer. So the best way to think of this is think of it as it's almost like there's an imaginary negative 1 in front of the d, right? And it's being multiplied by d. So if we think of it as an imaginary negative 1 times d, that's going to be easier for us to solve this, right? So we know that when you see a variable by itself, there's automatically, there is a 1 that we just don't see. But now it's the same idea here. If you see a negative sign in front, it's automatically assumed it's negative 1. So now I have to think to myself, all right, well, how can I eliminate the negative 1 there? Well, all I need to do in this case is simply divide by negative 1. So I can eliminate that negative 1 in front of d. So when I divide by negative 1, I end up with d is equal to positive 24. And this is my final answer there. So I hope that kind of makes sense. Like I said, I went step by step with these ones because I want to really make sure that you understand them. And this is really the basis of what we're solving. Of course, the questions will get a little more complicated, but believe it or not, if you can kind of follow that, then that's the big basis of what we're doing here. Okay, so now let's solve equations that have variables on both sides. So this follows the same idea. There's just one extra step, is that we have to figure out which side the variables will go on. Okay. So I'm going to eliminate this so we can see more drawing. Sorry, you can see the work here. So in the first one here, I have 4x minus 1 is equal to 2x plus 18. So I have to think to myself, okay, well, I want to move all the variables. I want to make sure that all the x's are on one side and all the numbers are on the other side. So what I'm going to do first is I'm simply going to decide where should first, before anything else, I'm going to decide where should the variables go, which side should they go on. Well, I could move the variables to the left-hand side or to the right-hand side, and technically it shouldn't make a difference which side you move it to, but you always want to be strategic about this. The general rule here is that you should move the variables to the side that has the larger coefficient. So because the 4x is larger coefficient than, the 4 is a larger coefficient than 2, I want to bring it over to the left-hand side. You could do it to the other side, but then you'd end up with a negative coefficient, which just makes it a little bit more complicated. So generally, if you can avoid negative numbers, try to avoid them, right? It's not always avoidable, but there are ways to try to avoid it if you can. So what I'm going to do is I'm going to take away the 2x on both sides. And the reason I'm taking away 2x on both sides is because I'm not just moving the 2, I'm actually moving this whole entire term to the other side of the equation. So in order for me to move that term 2x, I'm going to subtract off 2x on both sides. And when I do this, I end up with 4x minus 2x on both sides there. And then what I end up finding is that this gives me 4x minus 2x, which is 2x minus 1. And this ends up giving me, and of course these cancel out, and then I end up with 4x minus 2x, which gives me 2x. And I end up with 2x minus 1 is equal to 18. And again, where is the 2x on the right-hand side? Well, we subtracted it off when we moved it over to the left-hand side there. So now I end up with 2x minus 1 is equal to 18. So what's my next step here? Well, my next step is to think to myself, well, this is just like the other question that we did before. Now that we have all the x's on one side, this is a little bit easier. All the x's are all together, but the odd one out, the odd man out in this case is the negative 1. That negative 1 isn't where it's supposed to be. We want to move it over here. So to move it over, we had to think, all right, well, what's the opposite of subtracting 1? The opposite of subtracting 1 is to add a 1. And when I add 1 on both sides, I end up with 19. So we get 2x is equal to 19. And we're almost done here. We're near the end. So now I have 2x is equal to 19. Now, if I want to get the x by itself, keep in mind that I'm multiplying by 2 in this case. So I have to think to myself, well, what's the opposite of multiplying by 2? The opposite of multiplying by 2 is to simply divide by 2. So I divide by 2 on both sides, and then I end up with x is equal to 19 over 2, and I can simply leave my answer as 19 over 2, or I could technically write it as a decimal, and that would be acceptable. It's 9.5. So that's my answer there. So I'm going to do the next example, and I hope you don't mind. I'm just going to erase this. So we have, sorry, just want to erase this. For some reason, it doesn't seem to erase. Okay, well, it's not erasing there. That's fine. Don't worry about it. So now we have our next one, 6x plus 3. Just going to eliminate that there, is equal to x minus 5. So again, same idea as before. My first strategy is to figure out where the x's should go. So because I have a larger coefficient on the left-hand side, I probably want to move all my x's to the left-hand side in this case, right? So that means that so I want to move the variable x to the other side where we have the 6x. So to get rid of this this variable here, I'm going to be subtracting off x because that's the opposite of adding an x, and this is automatically just, you know, if there's no sign in front, it's positive, right? So then I'm going to be subtracting off an x on this side as well, and then I end up with 5x. 6x minus 5x is just going back to like terms, right? I'm just subtracting off like terms. And then I have 5x plus 3 is equal to negative 5. Now my next step is to move the positive 3 over to the other side. So to move the positive 3, I'm simply going to subtract off 3 on both sides. And when I subtract off 3 on both sides, I end up with negative 5 minus 8. And negative 5 minus 8 gives me negative 8. And now I have 5x is equal to negative 8. So now I think to myself, okay, well, I have 5 times some variable is equal to negative 8. So what is the opposite of multiplying by 5? The opposite of multiplying by 5 would be to divide by 5. So I'm simply going to divide by 5 on both sides, divide by 5 on both sides, and then I end up with x is equal to negative 8 over 5. Which ends up giving me negative, well, I can leave it as is, negative 8 over 5, or I can write that as negative 1.6. So hopefully this is making sense so far. And then for the third question here, I'm just going to start from the beginning. So I have 9x minus 4 is equal to 3x plus 18 minus x. So same idea as before. I want to think to myself, okay, well, which side, before I even start, this one's a little bit, actually, we have an extra step here. This one's a little more complicated because of the fact that there are two x terms on one side, right? So this is kind of throwing me off because I'm not really sure how to deal with that. I could try to move, so I have 3 terms actually that have a variable x there. So before I do anything else, we kind of go back to what we talked about at the very beginning. You always want to add up the like terms. You want to move numbers and variables to the same side. And of course, if they're on the same side, then you add them up like terms, because we know variables, all the x's are like terms in this case. So before I even move anything around, it's probably best if we actually just simplify this expression. So if I have a 3x and then I have a negative x right there on the same side, if I have them on the same side, then I can simply add them like terms. There's actually nothing really too special here. So what I'm going to do is I'm going to take the 3x and I'm going to add a negative x, or I can just think of it as 3x minus x. And what does that end up giving me? Well, we know that 3x minus x is 2x. and on the other side I have 9x minus 4. Okay, so what do I do next here? Well, my next step is to move all the x's to one side. Now, again, I end up with 2x here and 9x on the other side. It's still recommended that you always move it to the side of that has the larger coefficient. So the 9 is obviously larger than 2, so I would move the 2x over to this side. Now, remember, I can't just like move a number over. It's not really how it works. What I'm going to do is if I want to move that 2x over to the other side, I simply subtract off 2x, right? I subtract off 2x on both sides like this. And when I subtract off 2x on both sides, then I end up with negative 7x minus 4 is equal to 18. And then my next step here is to think, okay, well, now I have 7x minus 4 is equal to 18, but there's still a number that's kind of sticking around, right? It's not in the right spot. So this negative 4 shouldn't be there. It should be moved over here. So how do I move that negative 4? Well, I simply do the opposite. I use the inverse operations. So the opposite of subtracting a 4 is to add a 4, and I do that on both sides. And then I end up with 7x is equal to 22, and I am almost done here. So now I have 7x is equal to 22. I'm just going to do it over here so I have space. So what should I get rid of next? Well, I have 7x. I know what 7x is equal to, but that's not very helpful. I just want to find out what x is equal to. So remember, this is multiplication. So what is the opposite of multiplying by 7? To divide by 7. So I divide by 7 on both sides, and then this ends up giving me x is equal to 22 over 7. And you can definitely leave it like that, or you can find out what the decimal equivalent is. But I would just leave the answer as is. Okay, so hopefully that's kind of making sense so far. So this, to be honest with you, this is actually a very big and a very important lesson as well, I would say, how to solve equations. So I actually do have more to cover in this lesson, but I figured just because of how lengthy this video would end up being, if I kind of combine it all together, I'm actually going to kind of break it down into other parts. So I'm actually going to leave, there is more to the lesson. So we're not done the lesson yet. I still want to go over a couple more different tougher strategies. But just so you know, for now, I'm going to leave it as is. We'll talk about the distributive property and how to work with fractions. But I'm actually going to leave that, if you're okay with it, I'm going to leave it for Monday's lesson. So we'll kind of continue on. Having said that, I think some of you are already pretty familiar with solving equations. So if you feel pretty comfortable to just continue on with the homework, please do so, okay? But again, for now, I'm just going to sign the questions in section 4.2. I'll leave 4.3 for Monday. But again, I know some of you are probably ahead of the game. You've probably solved equations like this before, so you feel pretty comfortable. So you can definitely move ahead, okay? And that's all for now.